Hello, my name is Said Ruhula Majidi, and I am using Microsoft Excel for this project in order to build a machine learning model to predict power output from a combined cycle power plant. The goal is to estimate net hourly electrical output PE based on 4 ambient environmental variables: temperature AT, vacuum V, pressure AP, and humidity RH. This is a classic regression problem where the output is continuous. I'll switch now to the Excel file I have prepared in order to walk you through the model and to get to the evaluation. So here in the first 5 columns, you will recognize the data set we have received. 4 columns, the 4 first columns, the features, and PE is the output. In step 1, I randomly shuffle the data set in order to avoid bias in the order. Second step, I split the data set into train and test set data set, which is 80/20. Based on this training and data set, I have run the linear regression, which is in this data analysis tool, and you can see it here. This is the data which I have included. It came up with these beautiful outputs. We have the predicted PE resulted in this column, and importantly for calculating later on the impact on the test data set are the coefficients with the intercept and the AT. What happened for the test data set? I took the intercept, added the actual values from the data set, AT, in this case, times the coefficient. I did the same for the feature V, AP, and RH, each times with the coefficient, and came up, for example, in this case, with that value. You see here the values from the data set times the coefficient. So I came up, completed the predicted PE. Next step 4, I calculated the error between actual PE and the predicted PE. I squared then the error in order to apply it in the root mean square error formula, which is here. And I calculate the absolute error in order to use this in the mean absolute error formula, which is in here. In the end, I came up with these data sets for train, this results for the training data, and this result for the test data set. You see in the results that model 1 shows strong performance of both training and test sets, and there is a minimal difference between training and test errors. That means the model generalizes well without overfitting. Now, in order to compare this data set to a second alternative model set, I reduced the features. I dropped RH in order to see if the model performs just as well with fewer features. That's the first. The second, I have changed the training and test split from 80/20 to 70/30. This is to see increasing the number of unseen data in the test rows. Then I followed the step as we explained before, predicted PE with a linear regression. I came up with the predicted PE for a training data set. I calculated with the coefficients the predicted PE for the test data set in yellow. You will see here exactly, and I calculate again the error, the squared error, and the absolute error, and the result were these 4 values. You will see that model 2 is slightly performs well, but with a slightly higher error across all the matrix. For example, test RMSE rose from 484 to 4.91 megawatt, and test MAE from 3.73 to 3.88 megawatt. The difference, though small, but is consistent, and it reflects both the removal of the feature of the predictor and the more demanding test split from 70/30. I put this together and to compare in one view. This data I explained before, the differences here which result between the 2 models, and model 1, as mentioned before, remains the better performing model with lower errors and slightly better generalization. And model 2 shows that even with the simplified and tested more rigorously, performance degrades only slightly. What does it mean and what does it show? It shows that the model is robust and RHR, while helpful, is basically not essential. Let me go back to conclude. And in summary, I built 2 regression models in Excel to predict the power output from the environmental data. Model 1, using all 4 features, achieved strong results with low prediction errors and no overfitting. And Model 2 simplified the model and helped well under a tougher test split, confirming the system is both accurate and stable. I appreciate the opportunity to have learned how to build this model. Thank you very much, and thank you for your attention.